How is AI fairness mathematically defined? Imagine you're trying to teach a computer to make fair decisions without bias. How do we know if it's truly fair? That's where mathematical definitions of fairness come into play. These are like rules or formulas that help us measure whether an AI treats everyone equally. They turn ethical ideas into numbers and comparisons that we can check and improve. First, fairness in AI means that the system's decisions should not unfairly disadvantage any person or group. Think about a loan approval system. If it favors one race over another, that's unfair. Sensitive attributes are characteristics like race, gender, or age that should not unfairly influence the decision. These definitions help us set clear standards to see if an AI is being just or biased. One way to define fairness is called individual fairness. It says that similar people should get similar results. For example, two job applicants with the same skills and experience should have the same chance of getting hired, regardless of their gender or ethnicity. To do this, we need a way to compare individuals based on their features and ensure the AI treats them consistently. Another common idea is group fairness, also known as statistical parity. This means the AI should give similar outcomes across different groups. For example, the percentage of people approved for loans should be roughly the same for different racial or gender groups. We measure this by comparing the rates of positive decisions or errors across these groups. Equalized odds is another way to look at fairness. It requires that the AI makes errors at the same rate for all groups. For instance, a medical diagnosis AI should have similar false positive and false negative rates for different racial groups. This way, no group is more likely to be misdiagnosed than others. Predictive parity focuses on the accuracy of positive predictions. It says that when the AI predicts someone is qualified or suitable, that prediction should be correct equally often across all groups. For example, if an AI says a candidate is qualified, it should be right about that equally for everyone, no matter their background. But here's the tricky part. These fairness definitions can conflict. Achieving perfect fairness in one way might make it impossible to be fair in another. For example, making sure everyone is treated exactly the same individually might clash with ensuring equal outcomes across groups. Also, adding fairness constraints can sometimes reduce the overall accuracy of the AI. That's why developers need to balance fairness with performance and be transparent about their choices. In real-world applications, these fairness ideas help guide the design of AI systems like ChatGPT, DALL-E, and Midjourney. They also influence tools used for hiring, content moderation, and personalized recommendations. Ethical AI development means constantly checking and fixing biases in data and models to keep fairness at the forefront. So, in simple terms, AI fairness is about turning ethical principles into measurable rules. These rules, like individual fairness, group fairness, equalized odds, and predictive parity, give us a way to see if AI is treating everyone justly. They help us build smarter, fairer systems that respect everyone's rights and dignity.